talk about, get rid of some of the cobwebs, and talk about the ones you have questions about. So here we go. Pre-quest number 1. Question number 1 says, these are all calculator problems. You need a calculator. It says, convert to rectangular coordinates. Now, what does that mean I'm looking for? What do I need to find? I need to find X and Y. And I know I haven't seen you in a week, but prior to that, I bet I said it 15 times a day. How do you find X and Y? X equals R cosine theta. Y equals R sine theta. So what is X going to be in this problem? 3 cosine 162 and 3 sine 162. So I make sure my calculator is set in degrees, and I type 3 cosine 162 negative 2.85, 3 sine 162.93. There's the answer to the question. How long did that take? 15 seconds.
I think I have the wrong paper because I don't have that problem.
No, look in your other pile of stuff. I must have given it to you another time. All right, here we go. Convert to polar coordinates. All right, now what does that mean? What am I looking for? Polar coordinates. What am I looking for? R and theta. So somehow I need to find R and theta. All right. Now how do I do this? I do it a little differently. I don't use these formulas. How do I do it? What do I do?
You graph
I graph it. I draw a picture of it. So over 3 down 4. Now, this is R. Would you agree? All right, so do the Pythagorean theorem. And what does R turn out to be? 5. So R is 5. Now, how do I get theta? Well, I use my calculator again, right? How do I do it? How do I find, I need this angle right here. That is not the answer right away, but I need it. How do I find that angle right there?
You can take it by.
Well, actually, in this case, you could. I usually stay away from the hypotenuse because it's usually a radical. It's not in this case. I usually just use tangent because those are the two numbers that are going to be given, your x and your y. So I do second tangent, 4/3. Now, first thing I leave the negative off. If you want to leave it on, you're just going to get a negative answer. It doesn't make any difference. So I'm going to second tangent, 4/3, and I get 53.13. Now, that is not the answer. This is. Right? So I'm going to subtract that from 360, and I get 306.87. All right, so far so good. Convert to polar or trigonometric form. 2 plus 3i. Now, you have already done this problem almost exactly. it says convert to polar. What does that mean you're looking for? What are we looking for? R and theta. So we want to convert this to this form. That's polar form. I need an R and a theta, CIS, cosine I sine. Now, isn't that exactly what we just did in this problem? What is our X and our Y? 2 and 3. So I'll draw a picture over 2 up 3. What's my radius? Root 13. This is my angle, and this time it is the angle. How will I find it? What will I type on my calculator to find that angle? Second tangent, what? 3 over 2, yeah. And it's 56.3. And can I use that angle this time? Yep, because it is in quadrant 1. So my answer is root 13, CIS 56.3.
What if it's in quadrant 2?
Then you gotta figure out what it is, yeah.
So only quadratic so.
Yep. And number 4, convert to complex form. Well, you have already done this problem too.
So just root 13.
5 CIS 100. What's 5? That's your radius. What's 100? And what are you looking for? You're looking for X and Y. I just left this on the board. How do we find X and Y? R cosine theta, R sine theta. So for our problem, it will be 5 cosine 100, 5 sine 100. So 5 cosine 100, negative 0.87, 5 sine 100, plus 4.92i. Remember, I goes with the y. Now, look at problem 1 and problem 4. The math was the same. What was different about problem 1 and problem 4? Problem 1, how did I write my answer? As an ordered pair, coordinate. Because that's the way the problem was, right? Look at problem 4. Is there an ordered pair in problem 4? No. So I wrote it as my x plus yi number. Not x comma y, but x plus yi. All right. Convert to a polar equation. Well, I'm going to leave this right here again. I'm using this again on problem 5. Because what am I going to do with the x right here? What am I going to do with that? I'm going to take it out. And what am I going to replace it with? R cosine theta. So 2r cosine theta plus what? 3, not 3 sine, 3r sine theta equals 1. And there's the answer to the question. Do not look at me and say this is hard stuff. It is not. Now 6 is a little bit tougher than 5. Who remembers how we start a problem like this? Does anyone remember that? What is the definition of sine theta? What? No, the definition of sine. What's the definition of sine? What's sine?
Opposite over.
Okay, opposite over hypotenuse. Okay, I need letters. I'm not gonna put opposite and hypotenuse into my equation. What is the letter definition of sine? Sine is y over r. Oh my, we have to remember that. Sine is y over r. So I'm gonna go ahead and replace sine with y over r. What if that had been cosine? I would replace it with, what's cosine? X over r. What if it had been tangent?
Y over X.
Y over x. All of them you can replace. So whatever function you've got, sine, cosine, tangent, whatever you got, replace it with its definition. Now, who remembers the next step? This is always going to be a fraction. When you take out, it doesn't matter whether it's sine, tangent, secant, this is always going to be a fraction. So step 2 is always going to be get rid of that fraction. So what will I do to get rid of that fraction? Multiply by r. Multiply both sides by r. Now, you've memorized these. There's one more in that list you were to memorize. Who remembers the last, what was the last thing in that list that you were going to memorize? X squared plus y squared equals r squared.
Can we just eliminate that step?
What step?
The second one? The square? Where we have the square? Or sometimes we'll have a.
No, you're always going to get rid of the fraction. So you're going to do whatever, you're going to cancel out that denominator.
Isn't the r going to be there every time though?
No.
No?
No, what if it's secant? Then it's r over x.
Okay.
If it's tangent, it's y over x. So it's only going to be an r if it's a sine or a cosine. So it'll be an r a lot of the time, but not all the time.
Secant would be an x, isn't it?
Yeah, it'd be an x. You multiply both sides by x. All right, so what am I going to do with this r squared here? I'm going to replace it with x squared plus y squared. Okay? And that's it, you're done. All right, number 7. All right, these are the rules we talked about at the end of last week. Let's see, does anybody remember how we multiply these guys? It says we want to multiply them together. Anybody remember how that works? We have a rule for that. We multiply the r's, yes, Lauren, and we add the angles. So the answer would be 48 CIS 250. Very good, Lauren, thank you. So we're going to multiply the r's and add the angles. This is Bethurn, can I help you find something? Oh, okay.
I'm gonna take this, I'll bring it back.
All right, so we're going to multiply the r's and we're going to add the angles. Everybody good? Now, how do we do the division? Who remembers that? We're doing the division. We divide the r's, which I'm going to go ahead and reduce that. That would be 3/4. 6 over 8, 3/4. And subtract the angles. Now, I have a problem when I subtract, don't I? What's my problem? It's negative. I can't have a negative. There's two things I can't have. I can't have a negative and I can't have an angle bigger than 360. So what am I going to do to make that an acceptable angle? Add 360. So it will be 3/4 CIS 310. If the angle is too small, you add 360. If it's too big, you subtract 360. All right, and then finally number 8. The then we're gonna start graphing. This is the last actual problem. We are going to use de Moivre's theorem to raise negative root 3 plus I to the 5th power. Oh boy, who remembers how we start this? Draw a picture. Very good, Ashley. Draw a picture. Over root 3 and up 1. This is like a 1I right there. Yeah, what is the picture going to give me? What information am I going to get from my picture? I'm going to get the radius. Okay, let's do that first. What will the radius be? 2. Right? What else am I going to get from my picture? The angle, theta. Now, you'll have a calculator for this whole test, but you ought to be able to look at this and tell me how big this angle is right here. Look at these numbers. How big is this angle? That's a 30, right? Because that would be 60. Now, my radius is 2. What is my angle? Please don't say 30. My angle is 150. Now, somebody is going to stop here, and you're going to miss 3/4 of the problem. Because this is this. You still haven't done this part. This is the part we have to do next. So how do we raise this guy to the 5th power? We times 2 5 times. So we take 2 times 2 times 2 times 2. It's just like what you did here. You are multiplying these two numbers. Only this time, we have 5 of the same number. So we're going to take 2 times 2 times 2 times 2 times 2, so we get 32. What could you do if you didn't want to do 2 times 2 times 2 times 2 times 2? What could you do? 2 to the 5th power. So if you'd rather do that, you can do that. Now, what about the angle? What do I do with the angle? I add it up 5 times. So 150 plus 150 plus 150, 5 times. So that comes out to be, what, 750? Now you're almost there. But the angle is just too big. This happens almost all the time. You take something to the 5th power, you're going to get a big angle. So what do? If our angle's too big, we start subtracting, and this time you're going to have to subtract 2 of them. So it's going to bring it down to 30. It says answer in polar form. That's polar form. You are done. Now, you're going to plot a couple of points. So here we go. The first point we're plotting is 3 comma 2 pi over 3. Now, the graph paper here is the same as the graph paper in your note sheets, is the same as the graph paper on the Quest. So notice it's in degrees. So probably the first thing you're going to want to do is change this into degrees. So pi is 180 divided by 3, 60 times 2, 120. So we're plotting the point 3 comma 120. So we look on our paper, here's 120, count out 1, 2, 3 circles, there we go. There's where you put that first point. 3 comma 120. Now what about the next one? I've gotten wild and wacky on the next one. -4, 60. Now yeah, remember, -r, I don't even know how to deal with that. So I remember that if the radius is negative, what it really means is the point is plotted on the opposite part of the circle, which would be 180 degrees different. So this point is going to be plotted at 240. So it is 4, 240. That's where the second one gets plotted. It does not get plotted on the 60 line. It gets plotted on the opposite of the 60 line, which is 240.
If the angle is negative, what do you do?
If the angle is negative, you just go ahead and plot it. So, like this would be -15 and this would be -30. Remember, the negative angles just mean you go down. So there's no issue with the negative angle. The only issue is with the negative radius. All right, and then number 10, you're going to sketch. I'm going to go ahead and sketch it right on here. So I can redraw it. But I'm going to let my calculator help me. Now, before we do that though, before you type this in on your calculator, let's talk about it. Because Mrs. Ford is not going to set up your window for you. All right, I promised I would do that with a spiral. This is not a spiral. Everything else you're on your own for. You should know what this is. It's a rose. Now, we went through that long list. How come it's not a Lima sign? There's no plus or minus. How come it's not a lemniscate? There's no R squared. So it's got to be a rose. Okay? Now tell me about this rose. What does that 5 tell me? How long the leaves are. This gives me the length of the leaves. Now, what does that mean? If I want to set my window up then, what does that mean? I have to go out and up at least how far? 5. So maybe I will have X and Y be at 6 and -6 to give me a little extra space. Now, what does that mean? What does that tell me? That tells me how many leaves there are, and since it's an even number, there will be how many leaves? 4. All right, so I'm going to have my window set up. I am in degrees, so since I'm in degrees, what should my thetas be? 0 to... Kids, I'm in degrees. What should my theta be? Theta min should be 0. Theta max should be 360. And for your step, I would use 5. And what did we say we were doing for x min and y min? 6 and -6. Could we use 7 and -7? Yeah. Could we use 2 and -2? No, not big enough. It's got to be 5 or bigger, right?
How do you know what step?
It's just, if you're in degrees, just use 5 every time.
What's zero?
If it's in degrees and it's not a spiral. Now, I am going to take what's on my paper and I'm going to transfer it to this. Now, when you do that, you guys, make sure that your leaves are going out this far. Okay? Because I'm not going to take points off if your picture isn't perfectly symmetric and all that. But I am going to take points off if the leaves aren't the right length. You know those leaves are 5 units long. So when you draw it, it better go out to this circle. If this had been a 4 right here, then they would only go out to here. Do you see that? You are responsible for having it the right size when you put it on your paper. All right. Now, on the pre-quest, number 1, that we just went through, which problem gave you the most confusion? Or you think, boy, that's something I really need more practice on? Raise your hand if you have a problem that we just did, the 10 problems that we just did. Which one do we need to practice on some more? People. I know someone is confused about something, or you have forgotten something. Is that Bond? Are you awake, alert, and attentive? Katie?
Just like how to set things up on the calculators.
So another graph?
Yeah.
So she wants to do another graph, so let's just make up another equation. Let's try, let's try this one. Now, what shape am I anticipating this time? This is not going to be a rose. What is this going to be this time? It's going to be a Lima sign. Okay? Now, let's leave everything set up exactly as we had it. Let's type it in our calculator and see if we see a Lima sign. If we don't see the whole picture, then we'll make adjustments as necessary. Well, let's just leave it set up the way we have it and type in 2 minus 3 cosine theta and hit graph. Now, are you seeing the entire Lima sign?
Yes.
Yes. Now, you're going to take that picture and you're going to transfer it over here. Okay, I'll use a different color. Hopefully it don't get too confusing. Now, how far back does this Lima sign go? You can count on your calculator. You can count the hash marks. How far does it go? 5. That 5, by the way, is related to the 2 and 3. That's why it goes back 5. How about that little loop inside there? How big is it? 1. So we ought to be able to do this then. There's my little loop in there. And then it swings around out to 5. And there it is. So the green thing is my picture of what's on my calculator. Now again, I am not going to count it wrong if you're not completely symmetric. I mean, if this is a little bigger than this or something, that's fine. What I am going to count wrong is if this doesn't go back to 5 and if that isn't 1 unit. Because you can tell that from the picture on the calculator. You need to get the size right. Okay? And then the general shape. Okay? Let's try one more. This is what shape, by the way? This is your Lima sign. Is it a cardioid? No, because these two numbers don't match. Okay, let's try one more. Let's try this. Now, what are we expecting from this shape? What should this be? This is your lemniscate, which is going to have what shape? A figure 8. Now, what is special about typing in a lemniscate on your calculator? You gotta remember, you can't put in R squared. So what do you have to do? You gotta put it in as the square root of 16 sine 2 theta and as the negative square root of 16 sine 2 theta. Alright, so I got it in. Now, I haven't changed a thing, Katie. I'm leaving everything the same. I will change it if what happens? if I don't see the figure 8 I think I'm supposed to see, if it goes off the page, I'll have to make it bigger. My X's and Y's will have to be bigger. But this looks good. This is a nice little figure 8. Now, I'm going to draw this figure 8. But remember, Mrs. Ford is a stickler about size. So tell me about how long the little pieces of the figure 8 are. How long would they be? Not 16. I took the square root of 16, so they will be 4. So these guys are coming out 4 units. So here's my figure 8. Now again, if yours is fatter or thinner, I'm fine with that, but it's got to go out to that 4th circle. And it's situated on this diagonal. Sometimes it's the other diagonal, sometimes it's sideways, but this is a picture of that one.
I got like
Your windows.
no.
Your windows.
Is it possible for there to be more than just 2 pieces?
In this, it's always going to have this kind of equation. That number could be different, and that could be cosine, but that's always a 2 theta, there's always going to be 2. All right, anything else? What else do we need to talk about? What else do we need to talk about in terms of the problem? What else do we need to talk about?
Can we do another one with number 8?
For some reason, I'm not sure what you put in 20. You're supposed to put in theta. Okay. Anything else? What else do you have a question about? Mr. Devine. Mr. Devine. Put your phone away. That will be a DC. Come on, honey. I can tell. All right. So right now, nobody's got any questions. So what I think is, if I said take out a half sheet of paper, and I gave you a quiz over one of these questions, everybody would get it right, right? No. Which one would you miss? Let's practice it right now. Of these questions, which one would you miss? Number 2. All right, let's practice another one like number 2. Directions say convert to polar coordinates. So let's have the point -3, -5. There we go. We're going to convert to polar coordinates. Now, it always helps me just to stop a minute and say, okay, what does that mean I'm trying to find? I'm trying to find polar coordinates. So that means I'm looking for r and theta. Now, how do I find r and theta? I draw a picture. So I'll draw a picture, left 3, down 5. What will r be? The square root of 34. So that's my r. Now what about theta? Well, focus your attention on this angle right here for a moment. How will we find that angle? Second tangent. So second tangent 5/3. So I'll go to my calculator. Second tangent 5/3. And I get 59.03. actually 04. Now, if you put 59.04 right here, PJ, pay attention please. If you put 59.04 right here, you're gonna be wrong. Because the actual angle that you want is this one, right? Which will be 180 plus 59. So your actual angle is 239.04. Notice I wrote my answer as an ordered pair because it said polar coordinates. If it said polar form, it would look like this. This is your polar form. These are your polar coordinates. Same R, same theta, same math, just a different way of writing the answer. All right, we have time for one more. So who has one more on there that we need to practice on?
So whenever it says like to do something and you go into like the rectangular, you're always gonna do like the one on the back side.
Yep, yep. 'Cause anytime you're looking for anything rectangular, you know you're looking for x and y. And x is our cosine theta, y is our sine theta. Yep.
Wait, if it's a rectangular or like polar equation, that's like how that's written in ours.
No. Are you talking about like number 5? It says convert to a polar equation. No, if you're converting to a polar equation, that means you're going to still have an equation that looks like that, but your variables are not going to be x and y. They have to be r and theta. So we just these are the easy ones. 2r cosine.
Wait. No, I've got that. No, okay.
That's all you need to
180
know.
minus whatever we're at, and then all that. Does that make sense? And then where's the third one you added on? And then it's like 4
Okay.
360.
Class on Wednesday.